All right, welcome back from Christmas break. We were halfway through our database section before we went away. So today I'm going to start off with a little bit of a review of some of the database stuff that we've covered so far, as well as brief mentions of some of the other back-end topics that still will be in play. And then we will go ahead and move on to our two big topics for tonight, which are migrations and seeding. So on our last class, many moons ago, we did something pretty cool, which is we essentially created the same type of code base that we worked with on night one, but this time we created it from scratch. So instead of starting out with a bunch of things set up for us, a database methods, some baseline code, we did everything from scratch. So that was a pretty good moment. That was essentially, we created an entire backend database and all from scratch. And that's cool, and we want to do more of that, but you're going to find out tonight that we took a few shortcuts. There were a few things that we did with the database that weren't exactly done the right way. So tonight is all about learning some good practices on how to create our database, set up our schema for our database, and even populate it with some test data. So that's what tonight is all about. A little note, just so I don't get your guys' hopes up too much, on the syllabus on Training Kit, it says that we will be going over joins tonight. And I'm going to very briefly mention them, but we're actually going to save those for Wednesday. So no joins, not really any raw SQL tonight, just going to be using connects to do some more powerful stuff. So let's not waste any more time. I'm going to go ahead and share my screen. We'll do a quick review of what we worked on before the break, and then we will jump into talking about migrating and seeds with connects. So for all of you guys, we are going to be continuing off of where we left off. We created that code base from scratch on whenever that was, like 3 weeks ago. I've shared that a couple times in Slack because all zipped up. So I would definitely encourage you guys, if you have not already, to scroll up, find that code base and download it, because we will be building off of that for tonight's lecture. So I will share my screen and we will get back into that code base. All right, so here it is. Hopefully you guys haven't forgotten everything there is to know about Node. Up here at the top, of course, we have our require statements. Just a little reminder that require statements both work as a way of importing external modules and also importing different files in your code base. So we can see top, we're requiring both express and connects, two critical libraries that we're going to use to build our stuff. And then on line 4, we're actually requiring a connects file, which is just a different file in our code base. So that's how you want to get started, is by requiring any modules you'll need and any other files that will support whatever file you're working on. Down here is the basic setup. I think you guys are well familiar with how to use Express to set up your server, but a little reminder of what we did with connects. So connects, which is our database library, this is essentially what allows us to write pseudo SQL code using JavaScript, which we'll do more of tonight. So it is, when you require connects, it's actually a function. So in order to get this DB object that we can use to do fun stuff on the database, we have to actually call connects and pass in a config object. The config object was something we actually auto-generated using the connects command line tool. We'll talk a little bit more about that in a minute. But this connects file it's an object containing these different objects for different environments. So I don't know if you guys remember, but when this auto-generated, there were actually 3 different environments that it created. But we went ahead and pared it down just to this development object, because we're not planning on deploying this code. We just need the development. So this just gives it a little bit of information about where we can expect to find the actual database file. We added this use null as default in here, which will help us because we're using SQLite. So this thing's pretty simple, but it's going to be what actually makes our connects work. And we're going to be tinkering with this a little more tonight, so you'll see it again. So we went ahead and passed the development, so dbconfig.development, so the development object into Connects, and that gives us this db object, which has all sorts of useful methods on it. So down here, we can see that we're actually using the DB to write our database logic in here. So we have our port number, we have our, this is just Express. In the comments, I had put in some examples of some SQL code because, as a reminder, what we're doing with Connects is we're writing pseudo SQL code. So this is an actual SQL command in the SQL language. Down here, this is SQL logic, but it's constructed using JavaScript. So I'm going to go ahead and actually get rid of these because, as I mentioned, we're not really going to be talking about SQL itself much tonight. So I'll go ahead and get these out of the way so we can focus on the Connects and the JavaScript. So the rest of this file is basically just our CRUD endpoints. I cut some corners on these since the goal of our last lesson wasn't to review CRUD, but to practice with Connects. But these are the basic starting points for different get, put, delete endpoints and so forth. So we're not, once again tonight, not too worried about these endpoints, but you will need to be writing more endpoints for the homework tonight. So if you're feeling rusty on those, you'll have plenty of opportunity to practice it in the homework tonight. And of course, our server.listen at the bottom. So that's a review of what we did before the break. The most important stuff being this connects logic that we actually put in. So we're not going to be doing a thorough review of this connects logic, but you will need to be able to write it for the homework tonight. So this might be one of those scenarios where you're of course welcome to go back and look at the video from before the break, but I would really, if you're feeling rusty on this, because we haven't done much of this, and it's been a while since, since our last lesson, really rely on the Connects, documentation to help you out. You have a copy of this code base to refer to on the homework, but definitely rely on the Connects documentation when you're writing the logic and your endpoints for the homework tonight. So there's a little review of what we did. I actually want to say just a couple more things before we move on. The main thing that I want you guys to remember about this Connects logic is that for each of these CRUD endpoints, this create, update, so what am I? Retrieve, delete. See, I'm rusty too. For each of these endpoints, there's kind of a SQL analog. So we're used to thinking them more in terms of the API layer because that's what we've been doing since day one of this section. But now we've started to introduce it in new terms, in these SQL terms. So for example, a post, what we think of as a post in API terms is going to be an insert when we think about it in SQL. A get is going to be a select, which in Connects, you actually don't even need the word select. Just by passing the name of a table into our database, we automatically get a select. So we have a couple selects. Put would be considered an update. And delete is, well, it's just called a delete in SQL as well. So remember that there's an analog in SQL to these different endpoints that we're used to working with. Once again, as far as the syntax, documentation is going to be your friend. So that's a basic review. I want to go ahead and say, before we move on, if there's anything from our last lecture or just that I've mentioned in this brief review that you guys are feeling like, oh geez, I really want to be reminded of this before we move on, speak now. I'm happy to answer some extra questions about what we went over last time. I know it was a big break. So I'll give you guys just a second in Slack to ask any questions you guys have before we move on and start to talk about migrations. I see some typing, so I'm waiting for the typing to finish before I move on. All right, typing people, you're taking too long. Oh, wait. So one question about last time is the environment variable. So, and this is kind of an interesting point I mentioned last time, but absolutely not critical for you guys to know. And that's that this db config, because this is just a toy code base that we're only using in development, we can go ahead and hard code in, let's use dbconfig.development. In the real world, what you would actually do is get your process.environment variable and pass that in here. So this is something that if you were to deploy this code base, essentially it's a, I don't want to spend too much time on this because I think it's a little bit of an aside, but essentially the idea is that you could have an environment variable that's going to change depending on what environment you're in. So for example, if you were to deploy with Heroku, which we went over quite a few weeks ago, Heroku will automatically set that to production. So you can actually use an environment variable to dynamically change which of these config objects you're using. So don't get, if you're like, it just sounded like she said nonsense, don't get too bogged down on it. It's really not important for what we're going over today, but it becomes important when you start to write code that you actually do want to deploy and you want to function correctly in multiple environments. If you're curious about learning more about that, I would do some Googling about environment variables in Node. All right. And as far as if the environment is in the connects file, so the actual environment variable isn't in the connects file, but theoretically, in that case, there would also be a production object that has different settings based on what you expect to see in production. So in that way, this object actually contains different config objects for different environments. All right. Well, let's go ahead and move on to migrations. So I briefly mentioned at the very beginning that kind of the theme of today is to talk about some of the stuff that we did last time, but to explore some of the right ways to do it, some much better practices. And the first thing I want to talk about is migrations. So the purpose of migrations in backend coding is that they're our way of tracking and updating our database. So we use them to create different tables in our databases. We use them if we want to create schemas. So, and a little reminder of terminology. So once again, databases are collections of tables, right? So we have all these tables to keep track of all these things we want to store. The totally ridiculous example that we used last time that we're stuck with again today is crayons. So if we wanted to keep track of a collection of crayons, we might have a table to keep track of different boxes we have, and then maybe a table to keep track of the actual crayons themselves. And if we wanted to expand our database to be more inclusive of other art products, we might actually have a table for crayons, a table for colored pencils, a table for markers, and so on and so forth. Hopefully a table for glitter, because glitter is the most fun and horrible of all the art supplies. So yeah, that's what a database is. It's a collection of these tables. And in order to have a database and use a database, we have to create tables and define schemas. So a schema is where we define what goes in the table. So if we say, okay, our crayon table needs to have a color and it needs to have this and a name and so on and so forth. And as we also saw before the break, we can get really specific. We can indicate that some things are required, some things aren't. We say what type if we're expecting a number or a string or a Boolean. So that's what we need to do when we're actually creating a database, is define what tables are in there and what the schema of these tables are. So we did that in our last lecture. And can anyone remind me what tool we used to actually define our database? How was it, and in the most literal sense, how was it that we as a group created our database, which really is just this file right here, defined what tables and what schemas were in there? Awesome, DB browser. So we used a app called DB browser. SQLite is also an important tool, but slightly different. SQLite is our database management software. So it serves as a bridge between the actual database and us, the user. And there are a few different ways that we could access SQLite. One of the ways we access SQLite is actually through connects. So that's what's happening on line 7 here, is we're creating a bridge in the code between us and the database using connects, but also using SQLite. DB browser is just a different tool, kind of more intuitive visual tool for connecting with our database. So yes, DB browser is the tool we use. And tonight is kind of about why we don't want to use DB browser, why it's a good learning tool, but not such a good development tool. So we will be kind of replacing everything we did with DB browser tonight with stuff that we can do within our code base in connects. So yeah, so that's what we did last time. And I am actually going to get rid of our database now. Gone, just deleted it, moved it to the trash, because we want to redo the work of creating that database and those tables in it using only JavaScript. We'll still use DB browser a little bit just to tinker around and see what's inside of it. But for the most part, we're trying to get away from that tool. So before we talk about why we want to move towards connects migrations, or how to use connects migrations, let's talk about the why. So what we did, let me actually even open up DB browser. It's on my other screen and it doesn't want to come over. This is very strange. 1 second. There we go. Yes, the database is shy. All right, so what we did is we created a new database. Probably want to actually put this in grounds. So we create this thing, and then we can start to create a table, right? So I'm going to say, we're going to start with a boxes table today. And just to start, we'll definitely want to give it an ID. A little reminder that every single table in a database should have a primary key. And a primary key is something, in the most basic sense, we know it's going to be unique and it's not null. So that means we always know it's there and that it's always unique. And it's a way that we can, can you guys still not see the DB? How strange. That is super weird. What about now? Can you guys see it or not see it right now? Come on, guys, let me know. It's a yes or no question.
Negative.
Negative. Still can't see it. Okay. I don't know what in the world is going on. I'm going to stop my screen share and restart it and see if that fixes this.
Why possibly only sharing your VS Code screen and not the entire desktop?
That may have been it. What about now?
Affirmative.
Good now.
Yep.
Sweet. Thank you, guys. All right. So while you guys couldn't see what I was doing, I just created a new database, and then I'm creating a table here. So I was putting in an ID field, which is a primary key. As I was saying, primary key is going to be unique and not null. Essentially, that just means it's a unique identifying field for every single entry inside of this table. By default, you would think of it as just being called ID and being an auto-incrementing, which I'll do, auto-increment, an auto-incrementing number. Cool. So that's not a very interesting schema, right? Right now, it just has an ID and nothing else in there. So let's say I'm like, okay, this is a pretty cool table, right? This is useful. And I add it into my code base, and then I commit my changes, and then I push everything up. But there's not really good version control now. So let's say this is up on GitHub. There's a whole team of people working with this. And now I say, hey, wait a minute, actually, this is not a useful table at all. It would be super useful if this also had, you know, a crayon count and a brand and some other useful information in here. So then I update it. And what could happen is that just using Git, I could commit my entire database. And every time I push my code, I could push my entire database up. But that's not really how you want to do it. And especially when you're going to production, you're not really interested in actually passing around the database, right? The database is something that exists live and is actually being live updated by users. But you do want to keep track of the schema, because if you decide that now my schema is changing, that should go to production. So how is it that, you know, if I'm using a tool like DB Browser to make updates to my database as I'm working on something that's going to go live, that doesn't really translate to the database actually changing when it goes live. So hopefully you guys are starting to see why, though DB Browser is a really excellent tool for learning and tinkering, it really has some serious limitations when it comes to writing actual production code and code that's going to be shared amongst a team. So we need a better way to do this. We need a better way to create tables and to update tables so that we can actually track them, and so that our teammates and definitely the production code can make sure it's all on the same page. And that is the purpose of migrations. Essentially, a migration is like a snapshot of every change in the database. So every time you make a change, you're going to create a new Connects migration that keeps track of that change. So let me go ahead and jump back into the code base, and then we can see it in action so that you guys can understand how exactly these work and how to create them yourselves. So, all right. And one thing I just want to say, I kind of mentioned this already, but another point of clarification is that the purpose of migrations are to keep track of the shape of the database. So migrations are not meant to manage the data themselves. Migrations don't have anything to do with what is stored in the tables, the entries. They have to do with the shape of the database, which is to say, what tables are there? What fields what fields are in the tables? What constraints do those fields have? It's all about the schema, the shape of the database. That's what we're interested in managing with migrations. All right, so in order to work with migrations, we're going to need the Connects command line tool. That is something that we should have globally installed on the last lesson. So a quick way to check if you have the Connects command line tool installed is just type the command Connects. And you should see, let me make this a little bigger. So what you should see is something like this, where it suggests a few commands that you might run. So it's not going to do anything on its own because Connects by itself isn't a meaningful command, but it should be saying, hey, maybe you meant any of these commands. So if you do not have the Connects command line tool installed, first of all, the Connects command line tool isn't exactly the same as having Connects that can be locally required. So when you install something locally into the repository, that means, okay, I can require Connects and use this. Installing it globally means that you can actually use the command line tool, which we will need. So If that's not there, go ahead and do a global install of Connects. Make sure you also just do a general yarn install, because I know I hopefully got rid of all the dependencies when I zipped this up for you guys. So make sure you yarn install, and then if the connects command isn't working, do a yarn add global for connects. Worst case scenario, you can always do npx to run it, but ideally you just install it globally. All right, so once we have a, hold on, let me make this a little bigger. I'm gonna run this thing again now that we can hopefully see it a little clearer. So this shows us some of the things that we can do. It's not very readable, unfortunately, but we can do, first of all, there's an init command. Remember, that was the command we used to create this connects file. So the init command is great when you're starting from scratch. You will probably need it for the homework tonight. So this will give you a basic connects file with these different config objects in it that I mentioned earlier. That is a useful command, but we don't need it because we already set that up last time. We're more interested in the migrate and the seed commands for tonight. For right now, we're going to start with migrate. So these are the commands that will allow us to create new migrations, to update our code, and to even roll back to different versions of our database. So the very first thing we're going to want to do is create a table. And remember, I did recreate these. So let's delete these again. We want to start from scratch. So we might think the first step is to create a database, right? And when we went into DB browser, we had to actually create a database before we could do anything else. Luckily, while we do need a database, Connects will kind of take care of it for us. The first table that we tell it to create, it will automatically create the database for us. And it will do that based on what is in our Connects file. And I'm actually going to slightly change the path here. So I'm going to put this in a folder called data, because I want to keep everything database related in this data folder. So I'm going to change that path. Not a super important step, but kind of a nice thing for keeping things neat. Then I'm going to run a command. Let's do, oh wait, actually, going to do one more thing in my Connects file here. So I want to specify, remember I said, let's put everything in this data folder to keep it neat. We actually are going to update this to specify where our migrations files should go. So I'm going to create a new key called migrations, hopefully spell it right. And then within this migrations object, something called directory. So directory, and then I'm going to do, once again, data, migrations. So this is just saying, hey, I would like there to be a folder called migrations in a folder called data, and this is where I'm going to store all of my migrations files. So every single time we want to update our schema in any way, it'll create a brand new file tracking the changes within these directories. So now that I have that set up, let's go ahead and run our first migrate command. So connects migrate make. So connects migrate : make means I want to create a new migration. And then we want a specific name for it. So the first thing we want to do is create a boxes table, right, for all of our boxes of crayons. So I will do connects migrate : make. That means we're making a brand new migration. We're making some sort of change to our schema. And then we want a descriptive name. So this thing can be whatever descriptive name describes the change you intend on making. So let's try running that. Cool. So it created that. Uh-oh. It did not create the data folder like I wanted it to. Let me see what I did here. I might have to check the docs real quick.
Did you save the Connect file?
I might not have. I thought I did, but let's try that again. All right, let's see if that was it. Ooh, that was probably it. All right, thanks, good catch. So automatically, well, that's good because we saw what it would do by default is just create a migrations folder, which isn't the end of the world. But I've now put this in data. So now we have data. This is where our database is going to go. And then in here, we see our first migration file. And notice that there is actually a date and timestamp attached to the file name. So that will automatically be put on there for us, followed by the boxes table, which was the name I gave it. So this thing contains two different functions that are, so there's this little, they've kind of set up the structure of this for us already. There's two different functions that we need to define, up and down. So up is going to be the change we want to make to the schema, and down is going to be undo the change. So the idea is for every migration, we have to explicitly define both the change we want to make and a way of undoing it. The reason it's set up this way is because the migrations are meant to be able to go forward and backwards. So there's, of course, built in a way to keep the schema up to date, but there's also built into Connects a way to roll things back. So if you need to undo a change or go to a previous version, it's set up to allow you to do that. But in order for that to work, you have to define the down file as well, which will tell it how to undo the schema change. So that's what we're doing here is we need to define using Connects code, the table that we want to create, this boxes table. And then down here, we'll just be defining some Connects code to get rid of that boxes table. All right, does anyone have any, uh-oh. My goodness, I'm having all sorts of technical difficulties. Slack was not updating for me until a moment ago, so I apologize to all you guys. I was wondering why you guys were being so quiet. It turns out it was just my Slack. So let me see. All right, it doesn't seem like there's. All right, yeah, no wonder you guys were like, I was like, why aren't they telling me if the screen share was working or not? All right, so now that my Slack is hopefully working again, do you guys have any questions about using the command line tool or getting to this point before we move on? I want to make sure that we're all up to date with the config stuff before we start to actually write some of this schema logic using Connects. And I liked what Louis said about forgetting the commands. The least important thing for you guys to take away from this lecture is remembering the commands, because you can look at the documentation, you can rewatch the video. I think the most important takeaway is understanding what the commands mean and conceptually what we're trying to do. How to install the Connects client with yarn. So I would do yarn add global Connects, and that I already have done it, but yes, try yarn add global Connects. If you're using npm, you can use the -g. Which edits did I make to the Connects file? I changed the path to where I wanted my database to be stored, and then I added in this migrations key that is an object that contains a directory key set to the directory that I want my migrations to go in. So those were the two changes. So I can even just go ahead and plop this whole thing in Slack. what happened to the crayons.db file? So I deleted that. The crayons.db file was something we had created using DB browser, but we don't want to use DB browser anymore. So right now, and actually I'm glad you brought that up, because right now there is no database. We have zero database in our code base right now. So we're kind of going on faith that this is going to work and it's going to create a database for us. Why does the migration file have a very long number attached to it? We want to make sure that these are properly ordered. So this is the year, dates, and I think that's a timestamp of some sort. So, so yes, it will automatically put a timestamp number at the front of this to make sure that these are ordered correctly. So when I made the boxes table, is that a table that will track boxes? At this moment, it's not anything because we haven't written any code inside of these functions. So my intent with this file is that we will write code that will define the schema of a table meant to keep track of boxes of crayons. So that's what it will be, hopefully, once we finish writing our code inside of these functions here. So if you back to globally adding connects, just that command on its own should be enough to get it in there. You can double check by typing in connects, and you should see all these suggestions of different commands you might make. If you've done that and it's still not working, I would recommend running with npx. So what you could do, if you for some reason can't globally install it, you can always do npx connects migrate, etc. So it's essentially you're just doing whatever commands you would have been doing, but start it with npx. For anyone who did not have this globally installed correctly, a little reminder of the command I did already was I did connects migrate make. So that's the command. And then I went ahead and I think I called it boxes table. Would I use migration on a live database? So absolutely. That is one of the reasons that we love migrations, is that they work great on live databases. And once we go through and see a few examples of migrations, I'll talk in more detail about how and why these are so great and why they're really good for tracking with something that's actually going to production. All right, I'm seeing a request for a break. It's a little earlier than I usually like to do it, but I think now's a good time. We've done our review, we've set everything up. Let's go ahead and take our 5-minute break, and then when you guys come back, we will actually create our table using Connects code. All right, 5 minutes. And go. And yes, here's the, and I'll even type this command in here. I'm not going to answer any questions during break because I've had people request that I let you guys actually break during your break. So I see your questions in Slack, but I will wait to talk about them until we get back. Or maybe I'll just respond in Slack so there's a record of it. All right. And to answer the question about the Connect file, I just put it up on the page. What I posted did not include the module.exports. So I realize now that that was probably a little confusing. So make sure that you have, this is all the stuff I posted into Slack, and then the module.exports to make sure it is actually exported. All right, are you guys ready to actually write some schema logic? Well, we're doing it regardless, so. Okay, so the first thing to do when so we've used a little bit of connects, but we've never done anything like this in connects. We were using connects before the break to write queries, but now we're using connects to actually create tables and define schemas. So that's unlike anything we've done with connects. Where should we go to figure out what in the world we're supposed to type to make this happen? If you guys were trying to do this for the first time on your own, what would be a good starting place to figure out how to create a table using connects? The docs, yes, good old docs. So notice that there's this actually whole section. Well, there's the query builder, but then there's this whole section down here called the schema builder. So we are in a totally new world of connects. So everything that we need for writing the logic in these migrations is going to be found in the schema builder. So, and in fact, we can see a create table here. So, and we're actually going to need create table and drop table, because remember, we have to not only create it, but we have to write the code to undo what we've done. So there you go. Now, instead of just using the connects command, where basically everything we do is going to be connects.schema. And this is, in fact, the command that we want for creating connects.schema.create table. So let's go over here and do connects.schema.create table. So this guy, there are two parameters inside of this create table. And this is all explained in the documentation. There are two parameters here. The first is going to be the name of our table, which we'll call it boxes. And then the next is going to be a callback. And the callback will have a single parameter, which is the table itself. So the table will have its own methods that we can call on it to do table related stuff. So we're creating our table. Whenever we're creating a new schema, what is the very first thing we need? We already talked about this earlier tonight. Every table in a SQL database needs a field, a special field, an ID, or a primary key. Exactly. So it turns out there's a really easy, fast, convenient way to do this in Connects. It's a method called increments. So that's just saying, hey, I want an auto incrementing primary ID key on here. Awesome. So we took care of that. And then let's go ahead and just put one field in here apart from our primary key. I'm going to call this one count. It'll represent how many crayons are in this box. So, you know, you have your 24 pack, your 8 pack, so forth. Who is it who worked at Hobby Lobby? You're going to be our go-to crayon box expert if we have any crayon box questions in this lecture. Megan, that was it. All right. So we'll do table. So some of the other common methods that we'll use on table actually define what type of field we're putting in. Remember, we have to specify types when we're creating schemas. And we can see them actually over here. There are all these different methods that we could use to define types. So for count, we can use integer. So we'll do an integer and we'll call this count. And there's one more thing I want to put on this thing. I want to make this not null. So this ID is automatically going to be not null. But if we want anything else to be not null, and that just means that we're requiring our users to put a value in. If you try to submit something to the database where a not null field is missing, it will tell you, it will reject the entry. So there are some chainable things on here. So these chainables are things that we can chain onto different fields we create. We see that there's a unique one. We're not going to do unique because we might have 2 different crayon boxes with the same size, but we do want this not nullable. So we can chain on not nullable, and that's saying that this count field is required. So we've now created a very simple schema, but a schema nonetheless for our boxes. We know it's going to have a primary key, and it will have this count to keep track of how many crayons go in our box. All right, so we've completed our up function. Well, actually we haven't. I've almost forgotten one of the most important things in here, which is we need a return statement. This will not work unless we use a return statement with this. Oh, and one quick thing I just wanted to mention. Notice that these functions have 2 parameters, connects and promise. Connects you definitely need. That will give you access to the connects library so that you can actually call connects functions. Promise is just a promise library. I'm pretty sure it's Bluebird. So if you need to chain different connects commands together, you can use promise.all or other promise related methods. Going back to the documentation, here it is again. So notice that this table in their example, they've set the primary key, they've created a string called name, and they've actually put a timestamp in using this timestamps method. And down here we can see the, go away little scrolly bar. I don't know why that scroll bar is there. Well, you can't see it, but on your own copy of the schema, you can hopefully see that there is a actual SQL analog of how to write the same table. All right, and I see a question about exports up versus down, which is the perfect next question. So exports up is the change we want to make. So this is where we write the logic for whatever we're trying to do or change in the schema. Down, we need to write code that will undo this change. And we'll talk more about rollbacks in a little bit so you guys can understand why we want to do this. But essentially, it'll allow us to not only change our schema, but undo our changes if we need to. So let's go ahead, and the logic in here will be super simple. What is the opposite of creating a table in the SQL world? What would be the opposite of creating a table? Deleting in function, yes, but yes, dropping is the term I'm looking for. So deleting a table in just a little bit of terminology. Deleting is usually the term we use to refer to deleting an entry. So when we want to delete from a table, that means we're deleting all the contents of it. When we actually want to get rid of the schema, we call that dropping. All right, so let's go ahead, and there are actually two ways to drop tables in here. You can see that there is a drop table method and a drop table if exists. The difference is pretty simple. It's essentially drop table will only work if it exists. The drop table, if it exists, if it's not there, it'll just do nothing. So this is kind of a nice one to use because your code won't break if the table is already dropped for some reason. So we'll go ahead and use that one. So turn connects schema, drop, oops, dot, drop table, camel case exists. I believe that's all we need to do. Let's double check the documentation. Oh, we need the table name. Yes, that's important. So let's go ahead and pass in boxes. All right, perfect. So this is, and I see you guys are all talking about one of the classic XKCDs of Bobby drop tables. I feel like someone should post a link to that comic if someone hasn't already, because that is brilliant. I did, on a note about XKCD, I feel like I had to go back and reread all the XKCDs after I finished my math degree to catch all the math jokes I missed. And then after I became a programmer, I had to go back through and reread all the XKCDs to catch all the coding jokes that I missed. That's because I'm crazy and like to be a completionist. And if you guys don't know XKCD, it is brilliant, and please read it. Anyways, let's get back to the schema changes. And I see a question about, is there an equivalent for tracking changes to the data? That is an excellent question, and I will address that when we get to seeding. All right, so we have done it. We have defined what should happen when this migration runs, and we have defined what should happen when this migration is undone. But we still don't even have a database in here, right? So when we actually write this code, keep in mind that we haven't changed the database yet. We've just defined what should happen. So in order to actually change the database, and in this case, even create the database, we need to run another command. So this is a new connects command that we're going to run to actually do the migrating. So it's connects migrate :latest. So migrate : make is saying, hey, I would like to define a new change. I would like to make a new migration. I'd like to define a new change I want to happen to my schema. Whereas connects migrate latest is saying, okay, let's run all the migrations. And we noticed that it ran one migration, and it even told us this is the migration we ran. And woo, there's crayons.db. It has appeared. So I am going to bust out. I know I said we're trying to move away from DB browser, but let's go ahead and bust it out to see what's up. So let's open this database. This will allow us to make sure that the database is as we'd like. Okay, so we see that there's some stuff going on here, right? So there's some behind the scenes tables. We talked a little bit about the SQLite sequence that just keeps track of our primary keys. And then there's actually some tables behind the scenes that are keeping track of our migrations. It's nice to know they're there, but don't worry too much about them. What we really care about is boxes. And notice that it has an ID, a primary key. It's auto increment, it's primary, and we have a not null integer called count. So it looks like we have successfully created this table. Awesome. So that is our very first migration. Question about how did the crayons database come back? It came back when I ran connects migrate latest. So this is something that happens behind the scenes in connects. So the main purpose of this command is just to run all the latest changes. But it turns out that it does something else, which is that if the database has not been created yet, it will automatically create a database based on, and it will name it and place it based on the location and name in this file. So because I named it crayons.db and said it should be in data, it created it. We can even see that again if we want to. So if I go ahead and delete it again and run that connects migrates, see it reappeared. So when we add new migrations, which we're about to do, and run them again, it won't recreate the database. It'll just update it. And even though we didn't create it using DB browser, if we want to tinker around and make sure it's what we think it is, we can still use open database, find the new database, and check it out using this tool. So still useful, even though we're trying to get away from it. All right. Let's go ahead and create an update table migration. So I want to create a new migration. And this is important. So I want to update my table. And specifically, let's go ahead and create a Boolean called new. And that'll keep track of or we could maybe call it opened. That might be better. It'll keep track of if this is an unopened box of crayons or not. So it might be tempting to go in here and say, okay, well, I want to create table.boolean. Bad, 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 bad. Don't do this. Once you've run your migration, don't go in and tinker with it. That's the whole point of migrations, is that every time you change something, you create a brand new one. So it's kind of weird because we're doing a bunch in a row, which wouldn't normally happen. Normally you'd define your schema and then maybe a couple weeks later, you'd say, hey, actually, we really need this column. But we're kind of crunching down the timeline just for an example. But you don't want to alter your old migrations. That's bad practice. Especially, it's okay if you're just developing, but let's pretend that we've committed this, we've pushed this, it's part of the master repository, all of your teammates have this, and then you realize, oh, dang, I need another column. Now you have to create another migration, because migrations are how you're going to make sure that everyone's on the same page. And because this migration's already run, any changes we make, we want to be in a new one. So we want to create a new migration to add an opened column, a Boolean column to keep track of if our box of crayons has been opened or not. What is the first step of creating a brand new migration? Yep, we use the command line make. So that's connects, migrate, make, and then we need a name for it. So we'll call this opened column. And notice that a new file has been generated in here with new shells. All right. So before we used this connects schema.create table function. This is not the function we want. We are not creating a table now. So we are now updating a table. And it turns out that the command inside of connects, the schema command inside of connects to do that is just called table. So table on its own means update a table, whereas create table means create a brand new table. And once again, you don't need to memorize that. You can just check the documentation for that one. So similar to the create table, there's going to be two parameters in here. We want our table name and we want a callback. So now we can run similar commands in here on this table object to add what we need to add in here. So the syntax is going to be very similar. Because we're creating a Boolean now, we'll use the Boolean method on table, and then we can name this thing opened. We could use that not nullable chainable method if we wanted to make this required, but we'll go ahead and not make this field required. This one is going to be optional. All right, now we need a down. So what should, I know you guys probably don't know the commands to do this, but what should this down function do? What do we want this down function to do? Remember, it's meant to undo whatever change we did in up. I'll go ahead and start this off. Remove the column, exactly. So while I appreciate the drop it like it's hot reference, in this case, drop wouldn't really be the correct term, because remember, drop refers to dropping a whole table, and we're just trying to get rid of a single column. All right, so let's check the docs. Do you see anything that looks promising in here? Any methods that we might want to use? Ah, drop column. How convenient. And we can see there's also a rename column. That's another common one we might use. So for drop column, we just have to specify the column's name and we are good to go. So table.drop column, and we called it opened. There you go. We've defined the logic to add this column to our boxes table and the logic to remove it if we want to roll back. So let's go ahead and check our, I'm going to save this. Let's check our DB browser. Looks like boxes doesn't have that opened column yet. Can anyone tell me why my update has not appeared and it doesn't appear to have appeared in the database yet? Because we didn't run the migration, yes. So remember, just writing the code doesn't actually change the database. We have to run the migration before the database will actually change. So if we do connects migrate latest, cool, so batch 2. So now it's saying we've run now we've run a single migration. And this one is now the opened column. So let's refresh this. Come on. I think there's a way to. Okay. There we go. I had to reopen it, but there it is. And we see that it's a Boolean and we didn't put any constraints on it. Cool. So we have successfully changed this. Yep, I like this thinking about down as being the Command Z. So it's like the undo, exactly. So we want to be able to undo, but it doesn't, Connects is not smart enough to be able to figure out, especially if we're doing sophisticated stuff in here. It's not smart enough to figure out how to undo. So we have to explicitly tell it how to undo in case we decide we want to undo, which we will play with in just a minute. And here's what that other guy looks like. All right, so the next thing I want to do, there's a question of, would this become very large with too many migrations? It looks like it could get messy. Migrations are cheap, really. So it's true that there could be a lot of files in here, but it's much better than the alternative, which is not having any way of controlling, of keeping our databases on the same page. Also keep in mind that what we're doing right now is a little exaggerated, because usually what would happen is, a database architect generally would actually sit down and come up with the schema and put a decent amount of thought into it. So you wouldn't be creating a table and then being like, oh wait, I want this other file. So that's kind of, or I want this other column. So that's what we're doing right now just to test it. But generally speaking, the schema would be much more thought out. So when the schema is defined, a lot more thought would go into it. And then it would probably be a while before something comes up that you want to actually change. And really changing your database can be a giant pain in the butt because there's a bunch of code that also has to be updated. So generally speaking, you don't want to migrate unless you really have to. So migrations aren't something that you generally want to be doing all the time. But even if you are making a lot of changes, it's better to actually separate them out into these different migrations like we're doing. All right, so I want us to make one more change to this. I want to add one more column. I want a column called brand, and that will be a string. So brand will be a string. So if it's a Crayola brand, Crayon Box, or I don't know what the other brands of crayons are. We need our Hobby Lobby expert. Yep, so I want you guys to create and run a brand new migration that adds a column called brand. I'll put that, I'm only putting this up here so you guys know what I'm asking you to do. Do not create this migration in the same file. So create a new migration. So I'm going to give you guys a few minutes to work on this on your own. It's very similar to what we just did with the opened field. So go ahead and work on this for a few minutes, and then we'll come back together and go over it, and we'll talk about rollbacks after that. There's a question about drop column if exists. There is not a, at least not to my knowledge, there isn't a drop column if exists. I think that if you try to drop a column that doesn't exist, that it just, I'm pretty sure that this method basically works like an if exists. So if this column were missing, it wouldn't error out, but I'm not 100% sure on that. I'd have to actually try it out. And I'll go ahead and I'll put on a little timer for this. Let's give you guys 3 minutes to work on this. All right. I'm sorry you didn't get your last 11 seconds, but I think we're ready to move on. My gut says so. So the steps for doing this are pretty much exactly the same as the steps for creating this opened. So we want to start by creating a brand new migration. Remember, biggest faux pas would be to actually add the logic into here. And as a reminder, if we're imagining that what has happened is that we're imagining that what happened is that we updated the schema, these changes got committed, they went live, they were merged into the master branch, they were pushed to development, and then later we decided we wanted a new migration. If we really were just developing and said, oh, I want these 2 new columns, that would be perfectly fine to put them in the same migration. But in between all these, we're imagining that this code has gone up to production. That is when you need to create a new migration. So let's go ahead and run. So we'll call this one brand column. This. All right, so here we go. And remember, we want just the table method here. So we're still working with boxes. And now if we look over at our docs, we can see that string is probably going to be the best field that and we can call this one brand. And we will also make this one not required. And then down here, we'll do so we've defined adding the column and removing it. All right, and of course, our final step is going to be to actually migrate. And if we open this and reopen our database, all of the field will be in here. By the way, a little note is that by default, it will put a cap on how long a string field can be. 255 is kind of the default. I've always wondered where that number comes from. But yeah, so that's a nice thing to do, right? Because most of the fields, like a name or a brand, if it's longer than that amount of characters, that's a trigger. And when I was doing database work before I came to Lambda, this actually saved us a few times where there was some sort of crazy nonsense that our user tried to put in and it triggered our system because it was way too long. If you did have a field that was where you were actually expecting something longer, like if you were trying to store blog posts in a database, for example, you would want to manually up that limit so that your users could actually post something longer in here. There's an optional second parameter in the string if you wanted to change this to, let's say, is that 10,000 characters? So there you go. All right, so we have, and you guys are totally right that the idea of doing all these minimal changes in different migrations is pretty silly. What would normally happen is this would all be defined in the schema to start, but it's helping us see how this works. And to answer your question, you will do your initial setup of the database using a migration, and then when you want to change it down the road, you would do another migration. So the initial setup would be its own migration, and then if a month later you realized, oh, actually we do need to change the string limit on this, you could do a migration to update that. All right, so let's talk about rollbacks. So rollbacks can be a little confusing as to what their purpose is and when you would or wouldn't use them. So I want to try and help you guys understand their purpose. So let's start by showing you how a rollback works. It's pretty simple. It's just connects, migrates, rollback. And so it rolled back once. As you might imagine, I could roll it back again if I wanted. So this will roll back our very last change. So let's refresh this. And we can see that our brand field is now missing. So if we wanted to get that back, we could always do connects migrate latest. And it's back. So we can toggle between them at will. And to answer the question of can you set up multiple tables in one migration? Absolutely. So you could do, and an initial setup would have that. So that would be where you would probably want to use this promise parameter and do, let's look at the first one. So you'd probably want to do promise.all and then have a bunch of different create tables in here. Can we roll back to a specific migration? No. So you would have to actually run rollback as many times as you needed to get there. And that is, I think that you'll see why that is when we talk about when you would use a rollback. So that's my next topic, is when you would use a rollback and when you wouldn't. So here's an example of when you would want to use a rollback. Let's say that you are developing and you have your own branch, you're working on it, you're trying out a new schema, and something in the code totally crashes and you're like, uh-oh, and you want to quickly bring it back to the state it was in before. Then you would type in rollback. So you've just run a migration on your own branch. Nothing's been pushed, nothing's been integrated to the master, nothing's been deployed, but you just want to undo whatever you just did really quickly. Then you would do rollback. So that is the most common use case of rolling back. Another kind of related use case might be if let's say that a new change to the schema had actually gone to production and been deployed, but then a bug was discovered after the fact. And you wanted to actually play with it and figure out how was the code working before. So you're not trying to permanently undo the change. You're just trying to tinker with it and say, well, let me do some console logs and find out how this was working before. So I'll just do a quick rollback so I can compare how the code was behaving then versus now. So the main reason to do a rollback is really tinkering around, testing, exploring different versions of how the schema affects the other code. Here is how you do not want to use a rollback. Let's say you push a change to production and you realize it's bad, it's wrong, you want to undo it. You thought you wanted that brand column, but you don't. You want to permanently undo the change that you already did. In that case, you would not use a rollback. Now, here's the tricky thing. Can anyone explain to me why? Let's say you updated something to the schema, you realize, bad move, we want to permanently undo that. Why would you not want to use a rollback in that case? Perfect answer. Yeah, so I see an answer. Couldn't someone accidentally add it back? And in fact, it's even more extreme than that. Someone will almost definitely add it back because the next time you run connects migrate latest, it'll just put it back again. Yep, so a rollback is something that you temporarily do to tinker around. It is not a way to permanently change the schema. So if we did want to undo our change permanently, what would we have to do? We could delete the migration file, but that gets rid of kind of this log of what things look like at different times. A better way to do it, if the migration file has already been pushed and already been integrated into production, we want to be able to track those changes accurately. So what would be better is actually to do a brand new migration that undoes the change. So that's, hopefully we have enough quality control in our code that this wouldn't happen. This is something we'd like to avoid, is actually deploying something that should just be completely undone, but it might happen. And in that case, we would actually want to do a brand new migration designed to undo that change so that we have an accurate log of, okay, we added this in the schema and then we removed it. So luckily that migrate file would be really easy to write because all you'd have to do is take the up and the down from the last one and switch them. So we do want to avoid that. We want to avoid stuff going into production that shouldn't be there, but there are ways around it. And it's better to actually have an accurate log of everything that's happened. So that's rollbacks for you. Do any of you guys have any questions of how to roll back or when you would or wouldn't use a rollback? All right, you guys are pretty quiet. So let's move on to a new table. And yes, you would be flipping the up and down. You'd be flipping the up and down if you, wait, let me decode this question. You're essentially flipping the up and down on a rollback. It's more that when you run migrate latest, it reads the up file, and when you run migrate rollback, it reads the down file. So this is never, or not file, I'm sorry, function. So when you run latest, it completely ignores the down functions. But when you run rollback, it completely ignores the up functions. So why would you keep that change? I think the best, I mean, this is one of those things where I'm now second guess. I wouldn't be shocked if someone were to say just delete it. But the main reason is to actually have a log. So if someone else has a code from a specific point in time, it's better to be able to see how that fits into the whole. That I'm not going to pretend like that's canon or absolute golden wisdom that I just said. I'm sure someone could make an argument that in that case, it would be better to just delete it. And then your shame and embarrassment will exist in record for all of time. All right, so let me move on to, I want us to create a new table. We had just have boxes. We don't have any way of actually tracking our crayons yet, so we have to fix that. So I want to create a new migration so that we can actually create, a table to track crayons. And before we do this, I'm going to take a little minute to talk about the relationships between tables. And this is going to be the main topic of conversation on Wednesday. So in our schema, we want to have a table for boxes and a table for crayons. The crayon table actually keeps track of the specific individual crayons. So how are these, without even knowing the right terminology in relational databases, how are these related to each other? How does the crayon relate to the crayon box? The crayons are in a box. Every crayon belongs to a box. One box, many crayons. I feel like some of you guys do know some SQL terminology here. Boxes have many crayons, but a crayon can only have one box. That is, you guys are all exactly right. So when we're thinking about the relationships between related tables, so not all tables are related, right? If we had a table to represent crayons and a table to represent markers, those are totally unrelated. There's different art supplies. but the crayons and boxes do have a relationship. So we have to first establish what that is. And they have what we would call a many-to-one relationship. And you guys already articulated that really well. There are many crayons inside of one box. So the way that we represent that inside a SQL, which someone has actually already said, is with a foreign key, which is essentially we connect the IDs. So the idea is that every crayon should have a way of keeping track of what box it belongs to, which we would just call the box ID. So every single crayon we create will have a box ID that tells us which box it belongs to. It wouldn't really work if we tried to do it the other way. If we tried to put a crayon ID inside of a box, then we would have to have a bunch of crayon IDs inside of a box and things would get crazy and it just wouldn't work. So it's actually that the child has the foreign key that will point at the parent. So we will, if you guys are like, what is she talking about? We will talk more about this on Wednesday. I think it'll make more sense once I actually set up the schema for our crayons. So let me go ahead and create a new migration for crayons table. All right, so we've got another one. I'm going to snipe some of the code from this guy because it's going to look really similar to this one, just for the sake of time. All right, so once again, we're now using the create table method because we're creating a new table. Also notice that order matters here because the boxes, or because the crayons are going to reference the boxes, we had to create the crayons first. We still could have created them in the same migration. That would have been fine. We just have to make sure that if one table is referencing another, that the order is set up so that we're not trying to reference the box ID before a box is even a thing. So it's important that the crayons come second because they're kind of like the child of the box. All right, so we're gonna leave this guy, right? Because we still want it to have ID. Let's go ahead and put a field in here called color. So this will just be the whatever name is on the crayon. We could call it color or name, or sorry, string called color. And we'll make this not nullable. This one's required. And then finally, we have to say the box ID. So this one's a little bit of a mouthful. Definitely refer to the docs or refer back to this video on this one. It's hard to remember. So we would start by just defining an integer called box ID. Then we need something called unsigned. And I'm going to be totally honest with you guys. I spent a while before the lecture trying to figure out exactly what unsigned does and why it's necessary. I could not find anything on it. I didn't spend a ton of time. If anyone wants to solve the unsigned mystery, I will thank you forever. My guess is that it's saying that this integer can't be negative. I think that's what it means, but I'm not positive. So, but according to the docs, you need it, so I'm gonna do what the docs say. All right, now we need references. This is, because we could, on its own, even without the unsigned, we could do this and there would be a box ID, something called box ID in here, but we wouldn't have actually said it's meant to refer to the ID of something else. So this reference thing is what makes all the magic happen. So all these join statements that we're gonna play with on Wednesday only work because we actually put a reference in here. So this references, it won't crash without it, but it's important. So we're gonna say references ID in table boxes. So now what's actually built into the schema that this box ID is meant to reference the ID in boxes. So these guys have to match up or else you're going to be in trouble. Cool, thank you guys. So it can't be negative and it gives it a larger range. Nice, now we know what unsigned does. I think the trick is that I was trying to Google what connects unsigned specifically does, and you guys just looked at the general thing. Smart. All right, so there we go. That's all we're gonna put in for I think someone needs to mute. I might. What in the world? All right, hold on. All right, I'm trying to figure out where my magical unmute button or mute everyone button is. Come back. Right, the throat singing seems to have stopped, but. Yeah. Oh well, that's good for now. All right, so
My headphones, please.
If you put them on the charger in the morning, they'll be ready for you when you get home.
Nope.
Darn. You're smart. Dumb, 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 dumb.
all right, I'm gonna unshare my screen for a second so I can mute. It wouldn't let me mute all while the screen share was on for some reason. It's very strange. All right. There we go. We've had all sorts of interesting challenges throughout this lesson. All right. Okay, so, and then the last thing I want to change here is just updating which table we want to drop in the down. So there we go. We have defined a crayons table. Let's go ahead and migrate latest. Oh, what happened? Crayon table did not return. Oh, I forgot to save. Saving. Let's try that again. It might. Oh, so it didn't want to migrate it because I think I can roll back and remigrate it. Let's try that. Another situation where you would use migrate. Perfect. Why not use autosave? There is no good reason not to use autosave. I should use autosave. All right. Cool. So now we have created two tables that actually reference each other. So what's really great about this foreign key idea is, let's say that we wanted, going back to the SQL selects, way back from before the break. So let's say that we wanted to find every crayon in the crayons table where the color was equal to red. We could do a select where statement, easy enough. Now let's say we wanted to find all the crayons from a specific box. As long as we knew the box ID, let's say it's 4, still pretty easy. We could just do select all from crayons where box ID equals 4. So easy enough. But now let's say that we wanted to find all of the crayons where the box was a Crayola box. So if we tried to do select all from crayons where brand equals Crayola, we would have a problem because there's no brand in here. Brand actually comes from a different table. So that's where a join statement comes into play. And I don't want to get into the weeds of join statements because we'll deal with that later this week. But the important takeaway is that by setting this reference up correctly, we can actually select things from crayons based on properties from boxes. It's pretty awesome. We could also just create an overall table where you can see all the info from the box along with all the info from the crayons. So having these foreign keys actually opens up a whole world of different sophisticated things we can do with our tables. Question, can we roll back and alter the newest migration file? Yes, that's exactly what I just did. So I realized that I didn't alter it, but I functionally did because I had forgotten to save it. So once again, rollbacks are great for in the moment things. So if you run something and you're like, oh crap, I forgot something, you can easily roll it back and change it. You just wouldn't want to do that if that change had already been pushed and was already part of the master logic. As far as ID goes, a little reminder that in the boxes table, count is not the primary key. Count keeps track of how many crayons are in here. Even though we didn't explicitly define an ID, when we did this line here, that created an ID field. So we always want to reference the primary key. Bam. Thank you. All right. So this is all I want to do for migrations. So now we have, I know it's 8:40, but we're going to try and cram seeds into 20 minutes. We might go slightly over tonight, but I'll try and get it done as fast as we can without rushing through it. All right, so seeds. Let's take a minute to talk about what seeds are. Remember that migrations have to do with the shape. They have to do with the schema. They don't have anything to do with the data itself. Seeds relate to the data. Seeds are a way of putting in sample data. So if I wanted to populate this database, I could use my endpoints and start to add stuff in using Postman if I wanted to. That would start to get really tedious though. And it's not really easy to reset or repeat or whatever. So there are really, I think the main use cases for seeds are, we want to tinker around with our database. We can't really see how this thing is working very well because there's nothing in it. So what if we could just run one line of code to pre-populate it? That's really great for manual testing. It's critical when you actually write automated tests. So if I write a test suite testing my database, I need to make sure that the data in there is the same every time, and that for every member of my team, that we all have the same sample data. Because if our tests are all running against sample data, and my sample data and your sample data looks different, then we're in trouble. So the main reason for seeds is actually to set up sample data, to pre-populate our database with sample data. Occasionally you would seed in production. The main reason to do that is if you had something that you knew wasn't going to change very often. A great example is the states. If you had a states table that was full of, they're supposed to be full of all the states in the US, you could go ahead and seed that in because that's going to be the same every time. Or if there's some sort of starting info. But generally speaking, data should be actually created dynamically as you go. So seeding is more for testing than for production. And then to address the question that someone brought up earlier about, is there a way of actually keeping track of data at different points? So that is not what seeds are for. Seeds are just for giving you a baseline chunk of data that appears in your database every time exactly the same. But you do actually want to do backups on your database. So the question about how to keep track of the data in the database that's really a database administrator topic. Essentially what every database should have is just some sort of system of backups. Maybe in some cases, backups should happen nightly or monthly. Maybe those backups should happen every 5 minutes. It depends on the use case. So that is a whole nother topic. It is real and it is something that's done and it is important, but it's not really what we're dealing with tonight with seeds. But it was a good question, so I'm glad that that came up. Okay, so let's go ahead and create some seeds. So just like I said that because of this foreign key, order matters in terms of defining tables. Order also matters with seeding. So based on this, the fact that we know that there is this foreign key inside of our crayons table, which table do we need to seed first? Which table do we need to populate first? Boxes. So the reason we need to create boxes first is because we I mean, if you even think about it, literally, you can't really have crayons until you have the crayon box. Yeah, perfect. Kendra just said almost exactly what I said. Parent comes before the child. That's another good way to think about it. In the literal sense, we would just have no idea what to put in box ID until there are some boxes with some IDs. So let's go ahead and create some seeds. So once again, we'll be using the Connects command line tools. So, first of all, I want to update my seed path. So I'm gonna go into my Connects file and basically do the exact same thing I did with migrations. Just create so that everything is nice and inside this data folder. So I'm gonna do that first. And then I am going to seed. So what's nice about the migrations is they automatically create these timestamps. With seeds, you kind of have to do it yourself. So, so if order does matter, which it does when there are foreign keys involved, we have to create some ordering. And one thing I just want to say is seeds, migrations are really important. They're, you know, I've spent a lot of time talking about them and talking about how to use them because they're not something you want to mess up. Seeds are a little more loosey-goosey. So it's, especially since they're more of a testing oriented thing, we're not going to be as intense about them, but you do want to make sure that that you number them if there's foreign keys involved, like in this. So let's go ahead and do connects, seed, make, and I'll just do 01 boxes. So I went ahead and put that 01 in there so that we can make sure that this runs first. So we see the seed folder created and this thing is nicely pre-populated. So, so you always want to start by deleting all existing entries. You want a fresh slate every time you seed. So we're essentially saying, let's go ahead and grab boxes. We're going to delete everything from it. And then we're going to insert stuff. All right. So, we don't need to put IDs in because those are going to be automatically put in there. We do need, what is in our boxes again? We had count. And then we had, I think, brand. We don't need brand, but I'm hearing myself. I think someone is unmuted again. Please mute so I don't have to unscreen share. And then we had, what else did we put in there? It's been so long. We did so many different things to it. Oh, we had this Boolean called opened. That's right. All right, so we'll, I don't know any other brands. We'll just call this off brand. And then we'll do opened, true. Oh wait, actually we want, I'm pretty sure that SQLite stores these Booleans as ones and zeros. So 1 is going to be true, 0 is going to be false. And okay. Cool. So there you go. We have 3 different boxes of crayons that we can insert. So just like with migrating, the stuff isn't actually in our table until we run it. So the command for that is connects seed run. Uh-oh. This table name. Oh, oops. Definitely want that. All right, let's try that again. I'll change this to Rossart. All right, so we see that, let's go ahead and check inside here. What in the world? That doesn't look good. Oh, I forgot to fill in my counts. Jeez. All right, let's check it out again. There we go. So we see that everything's appeared in there. So notice that when I rerun this, it doesn't just keep adding them in. It deletes and replaces them. But there's something happening with my ID every time I run this that's kind of unfortunate. Have you guys noticed? The ID keeps incrementing. So this is not only annoying, but it's actually going to be extremely problematic because of that foreign key, right? Because when in a moment, I'm going to create seeds for my actual crayons, and I need to have an accurate foreign key. If I say that, if I run this the first time and there's a box ID 3, but then the next time that becomes box ID 6, that's going to be a problem. So it turns out that there's actually a better function than delete, and that is truncate. Truncate is almost exactly the same as delete. It will just reset the IDs. So let's try that again. Now it's back at the start. And every time we run this, we're still just going to have 1, 2, 3. So that's nice. That's what we want. Truncate is good. We like truncate. So let's go ahead and create some seed data for our actual crayons. So we'll go back to, come on. There we go. So I'm going to do O2. All right, so let's go ahead and change this to crayons. We want to change this to truncate. And then we'll change this to crayons as well. All right, I know it's almost the very end of the lecture, but I'm going to give you guys just a couple minutes to come up with some crayon data. So I'll give you guys just like 2 minutes to come up with crayon data, and don't post anything until the 2 minutes are up, but when it's up, feel free to share your sample data in Slack. So I'm going to set a quick timer here. And remember, it has to fit the schema that we created for crayons. All right, so you guys have 2 minutes to come up with some sample crayon data, and when the timer is up, share in Slack, but please do not share before the timer is up. Just trying to mute again, and now Zoom won't even let me mute all. My technology is trying to kill me tonight, or just being really annoying. But whoever's typing, please mute. It's driving me insane. All right, timer is up. Send me some sample data for crayons. Everyone, go. All right, what I see looks good, except I'm a little disappointed that we don't have slightly more ridiculous crayon names, but we can work with that. So this was what Stefan posted. I'm going to change this. Only 2 minutes. Look, done. Just made the names ridiculous. And all right. There we go. I feel like it's just like Ice Storm. Money Green, Lambda Red. Yeah, Lambda Red is better. Okay. I'll just call that one Sunset. Dexter Morgan Red. Brilliant. Death by Ninja Black. Okay, we gotta put at least, I feel like Death by Ninja goes in the off-brand box. Ah, come back. So we'll put that in box ID 3. Oh. Baboon behind blue. We should all, why are we becoming programmers? We should just be professional crayon color namers. Here, there's a lot of money in that field. All right, so we have all of my names are right. Let's go ahead and run this and see what happens. All right, so. All right, so we ran 2 seed files. Let's go ahead and see. Boxes should look the same. Nice. What would happen if I did this? I've now said Death by Ninja Black belongs to box ID number 4. What would happen if I tried to run this seed? Any ideas? You guys say it's not going to work. Oh, that's weird. It shouldn't have worked. It's slightly concerning. I wonder if we, I feel like I don't have the wherewithal to figure this out right now. Ideally, we set up this schema so that, not the table one, but the actual crayon one, so that this references the ID and, well, that's slightly concerning. That shouldn't happen. I will look into that and figure out how to prevent that from happening. But so I think it's too late in the day to tinker with that. Let's just go ahead and put it back in box 3. All right. So the final thing I want to do to wrap up our lecture is let's bust out Postman. We do still have endpoints in this thing. So let's see if we can get our, well, let me make sure my table names are the same before I get too crazy. Nice. So let's go ahead and just really quickly get out Postman as a reminder of how to use that and make sure this works with our actual endpoints. I've got to start my server first though, so. Oops, what is it, Yarn server? What do we got? Yeah. Postman. So we're gonna go ahead and do a GET request. Okay, cool. And then we could even do a post. Did we color? Yeah, aqua is fine. Let's try that. And then if we go ahead and do a get again, we will see our new color has been added. But if we were to run our seed file again, aqua would be gone. So we can tinker with this as much as we want, but remember when we run our seeds, it'll just start it back up at that kind of baseline point. So there you go. There's a question of, do we need to change the DB file path? No, we do not. That's automatically going to work because remember, the only DB file path we have anywhere in here is the one from the connects file. So the index will use the correct file path, even though we changed it from last time, because when we set up DB with that config file, it already connects to the path. So there you go. Let's talk about what the homework involves, and then I will answer any questions, and then I will let you guys go. And then I will sleep, and in the morning I will try and figure out why my foreign key constraint was not working the way I wanted it to. All right, so the assignment. So the assignment really does tie together everything we've learned. And one thing that is nice and awesome and kind of scary about this assignment is it's very open-ended. So there's a schema that it defines. You're going to have to build the schema using migrations. If you want, feel free to have 2 separate migrations for the 2 different files. If you want to play with the promise library, you could actually have both of these schemas in just one single migration. That's up to you. I would not recommend having separate migrations where you add every single field. That is very much overkill and not good practice. So you'll have to set up some migrations for these database tables and then endpoints. So we're never going to get away from endpoints. So admittedly, a lot of the work is going to be setting up these endpoints. Remember though that you're not just setting up endpoints, you're actually using connects to define the logic within them. So you can just write the logic straight into the endpoints if you want. If you want to challenge yourself, you're welcome to create a separate file with database helpers, and you can write those helpers. You can also go ahead and you can also, even if you want to, go ahead and create routers and actually have separate endpoints for different things. So make this as challenging as you want. If you're feeling rusty, just get the basic thing out, but you can implement a lot of the different things we've covered over the lectures so far in just this one assignment. So, yep, so, and the API here is you're playing with cohorts and students. There is a relationship with cohorts and students, very similar to crayons and boxes. And there are a bunch of different endpoints that you're welcome to play with as well if you want to make this a little more difficult. So there you go. That's the homework assignment for tonight. A lot of it is going to be review, but a lot of it is putting together a bunch of different stuff we've covered. This is a tough assignment, especially given how long of a break we've had. So is this a 2-day assignment? This, I believe, is only a 1-day assignment. So this is a toughie. It's probably going to take more time, especially given the break. So look at old assignments, look at old videos. But it's really important that we get all these things and actually tie them together. So any questions on the assignment, on the material, on anything? I'll try to keep question time short-ish because it's late, but ask away. How do we init? Good question. The square root of love is, there's definitely an I in there. Love is definitely a negative number. Alcohol. Alcohol I. How do I avoid getting multiple migration? Oh yeah, I'm sorry I didn't answer your question earlier about multiple migration folders. I think what happened is that I think that you had one thing in here and then you migrated and then it's changed. So to avoid getting multiple migration folders, make sure that this directory is set at the very beginning and that you don't change it. So make sure that this is set and defined before you generate a migration. Speaking of the connects file, there was a question about init. So I'm gonna actually go ahead and I will delete this. Actually, let's rename it. Cool. So this is not going to work anymore. Okay, so if we do, no. So if we do connects init, it creates a connects file. We don't need staging or production. The only thing that you absolutely have to make sure of is that you add in this, what is exactly the syntax? It's use null as default. Because we're using SQLite, we have to have this. So that's really the only thing you have to add in. You can change the file name if you want. You can add a migration folder if you want. You don't have to. This can just be the name of your database. The migrations can just be in their own folder. That's up to you. I like doing it the way I did with the data folder where everything's nicely put together, but you don't have to. It's important that you don't change the file name midway, or as we talked about, don't change the migration folder later down the line. But really the only, and you don't even have to delete those other objects. It doesn't matter. The only thing you have to do is add in this value. But you're welcome to define where the migrations go, where the seeds go, and where the database goes. So that is how you do connects init. So it's actually not that difficult. There's just one kind of gotcha that you have to keep track of. Any other questions? I'm gonna go ahead and delete this and put my old connects file back. When we create tables, it's always an object. Would we ever create nested objects, a table within a table? That's an interesting question, and I'm not sure I fully understand it, but I'm gonna answer it the way I'm gonna answer what I think you're asking. So if you don't feel like your question is answered, ask again after I'm done. So the first thing I wanna say is that keep in mind that a table is not an object. We can use JavaScript objects to represent tables pretty well, but a table is not an object. It is it's its own entity. And it kind of works like an object where there are keys and value. I mean, there aren't really keys and values. There's basically like a definition of what it's shaped like and then multiple entries. So a table really is its own thing. As far as creating tables within tables, that almost opens this whole topic of document-based databases. So within SQL, they're always just tables on their own. And the only way those tables connect is by these foreign keys. And we can create different join tables to represent different things, but there's just tables and they can connect in only one specific way, which is a key that references an ID in a different table. But if you wanted a database that was a little more crazy and had fields that contained different shaped things, you would want to use a document-based database, something like, oh my gosh, my brain is broken. What is the document-based database that everyone uses? Mongo. Mongo would have a little bit looser structure. So I'm not sure if that answers your question, but that's my best answer. Any other questions? And like, actually pretty much the definition of a document-based database is that a table, instead of table, it is an object. So that is kind of like one of the distinguishing, if not the distinguishing feature between a document-based database and a SQL database. All right, well, you guys are being pretty quiet. It is 10 minutes past when the lecture should have ended, so I think we will call it quits. All right, guys, it was a little bit of a crazy night back, various technical difficulties and children and typing and foreign keys going crazy. Welcome back, you guys. I hope you guys are nicely refreshed after break. If you're feeling like the wheels in your head aren't quite spinning at the speed you'd like, that's okay. We're just getting back to it. The homework is going to be challenging tonight. It's already a tough one. And with the break, it's going to be harder. So be kind to yourself, be patient, and you'll get back into the swing of things soon. All right, I will see you guys on Wednesday, and we will talk more about this fun relation stuff and joins. All right, I'll see you then. Good night, guys.